just do better.
There was a guy wearing sunglasses while writing code. He's like, you might be wondering why I wear these dark glasses. It's because light attracts bugs. And I chuckled to myself.
It's so dumb. Welcome everyone to another great podcast of the Do Better Dev Show. I am here with your favorite co-host, Nathan Calvin.
That's me. Hello.
Yeah, and me, your second favorite co-host, Gyan Mishra.
I did not realize that I was going to be promoted so quickly from second favorite podcast host.
I'm just feeling generous, it's 2021, it's our first recording for this year, even though we've been recording for a while, no one's going to hear this for another 3 months.
Mm-hmm.
But it's a great day, it's going to be a great year, and I'm just feeling great.
I like that attitude, Gyan, and I especially like that it started with me moving up in the world. Not every year begins that way, but it's literally the first day of the year, already got a promotion. I'm pretty excited now for the rest of the year and what it's going to bring.
Yeah, just because of this promotion, our stock value has increased from 0 to still 0.
But this percentage-wise, it was a big increase.
It was 100% increase on the $0.
That's awesome.
Yeah, there was some sort of multiplication involved, and that's why it's still 0.
Yeah, of course. That's how percentages work.
But exactly, yeah.
Cool.
Yeah, this is an episode about percentages and stocks.
Yeah, the shareholders will be real happy. Both of us, I know, are very happy about this.
Yeah, we're feeling great. We're happy. The price is up there with, Amazon.
I would love if in 3 months when this comes out, something crazy's happened and everybody listening to this is just like, what are they talking? This has not aged well. The stock market died in February. Don't they know? They're so insensitive.
Hey man, I got some cash sitting in the stock market, so no.
Sorry, I see that struck a chord.
Yes. I'm already worried. I'm gonna hoard all the cash in my backyard like a beagle.
Nice. Just watch out for pianos.
Well, YOLO, what do you do?
You only live once.
So take care of yourself, YOLO, brush your teeth before bed. YOLO, go to bed on time.
Wear titanium suits.
Wear titanium suits in case piano falls on you.
It's really all you can do these days, and I wouldn't change it in 2021. I'm keeping all of that safety in mind when I enter this year.
That's true. In 2020, we had weird metallic things showing up
in Utah,
structures in the middle of nowhere. Yeah. So in 2021, it may be metallic pianos. You just gotta be prepared.
Exactly. Yes. So with that warning that is now 3 months late to all the listeners, I hope you've been safe so far in the year, and we're happy to be here with you.
Yeah, and we hope your year has been going as great as we're predicting ours will go.
That's what I'm saying, yeah.
And everything we say on the show is a fact, so it's going to be a great year.
Oh, I'm so glad you said that.
Because this will not age well. But we'll find out in 3 months.
That's right. But in the meantime, Gyan, since we last recorded, if you can remember what has happened since then, anything good? Anything interesting? Anything you'd like to report back that was rad?
Yeah, I spent a week in Victoria, British Columbia, where we are from, and it was great. I hung out with my best friend. I couldn't see another one because I didn't want to infect him. But I basically quarantined with one of my friends, and we played games and played some more games. And it was great.
As he does.
As he does. He plays games on his own, and then when I went there, we played games together. It was a huge change in habits.
Yeah.
And I finished this book, The Happiness Project, that I was reading. Finally, I had to just sit through, and I didn't want to take any incomplete books into 2021. So I sat there and I finished it. Great book, very much recommend it. And then that's the 2 great things that happened to me in the last week.
It's almost creepy because both of mine are very similar. So I also, in the last week or so, arbitrarily decided I'm finishing that book before the end of the year. So I just read the rest of the system structured computer organization book. So it was like 300 pages, and just read it all. So I've now finished that book, and yeah, going into 2021 without having to knock away small parts of that book each day. So now I've got all the knowledge, obviously absorbed every word, and I'll go back and reference it when I want to. So they've got some good chapters, and the index is pretty well laid out. So if I need to brush up on anything, should be able to jump around fairly easily. But now that I've gone through the book, I at least kind of know what's going on in there. Excuse me. And then the other thing was video game related, which is for Christmas, I essentially bought myself as a present the 3 years of Xbox Live Gold. And I got 3 years because that's the most you're allowed to have on your account. So I bought 3 years of that, and then upgraded with this $1 option that they have to upgrade to Ultimate, where it includes Game Pass. And as far as everyone on Reddit and what my account says is concerned, I guess I now have 3 years of Ultimate, and that's pretty great. So if that's true, then yeah, I just spent a couple $100 and got 3 years of their game library and Xbox Live Gold. So in the last 24 hours, I've become addicted to Rocket League, and I'm now playing that a bunch.
Wow. I mean, excuse my French, but that sounds neato burrito.
I'll excuse it, but strong words are sometimes required, and
they are.
And I would say that
I could not think of a better way to describe that.
Nor could I. As you could probably tell, you took the words right out of my mouth. I didn't have anything to say after. But yeah, so that's been fun. Even message some old friends and just like, hey, do you still play games on the internet? Because if you do, we should play games. So that'll be nice. Reconnect with some people I haven't chatted with in a while, and maybe play some Rocket League or something.
Yeah, and by the time this episode comes out, if you guys are listening, go to Nathan's Twitter, hit him up, play some Xbox games with him.
Sure, if you're cool.
Yeah, I mean, everybody listening to this podcast is cool. Why else would they be listening?
That's fair. Yeah, I was gonna claim that they're just like every other stranger on the internet that I would be matched up with, but I guess not. If they know about the show, they're a tier above.
They are top tier. As some might say.
Top tier talent.
Top tier talent. T3.
T3. Well, see, I've been learning about T3 and T2 with this Amazon EC2 course that I've been doing, or not EC2, but Solutions Architect. And I just finished the EC2 chapter. So that was like 2.5 hours of stuff. And the course itself is apparently like close to 30 hours long. So this is going to take a while. But yeah, I'm about 10% of the way through the course, I guess. And a lot of it was sort of just solidifying stuff that I mostly knew, but couldn't have explained very well. And so, for example, they had like a mid-chapter quiz, and I think it was 13 questions, if I'm remembering correctly. And after doing the material, I got 13 out of 13. But I think if I'd gone straight into it without having done the material, it would have been more like 8 or 9 out of 13. Because there's some stuff that, like, I knew generally, and I could have guessed, but there's some stuff that was a bit more specific, where it has, like, these are the 4 different things that you can set on a security group. It was, like, IP address, DNS, and, like, some other things. I wouldn't have domain. I wouldn't have necessarily known which one was not correct and selected that out of the list, and it would have been a guess. So things like that I was just not super confident on. It's now shored up those things, and looking forward to the rest of the course and hopefully getting good at some stuff finally, because it's not my area of specialties.
Yeah, I am confident you'll be doing better every time you look at it.
Heck yeah.
Yeah, I'm also looking forward to some episodes, actually, from that course. Then we could just talk about some of the things you learned and educate our crowd with that.
Yeah, if I think that would be really good. If I'm able to explain some system design and general solutions architecting stuff by the end of it, then I'll know that I learned stuff. And if I can't, it's not a good sign.
Yeah, and then we'll just tell you to do better, because doing better is a recursive process.
I heard that somewhere from a semi-reliable source.
Semi-reliable source indeed.
So I guess we should probably start on the meat of the show today.
Yeah. In case you guys haven't read the title, because you were so excited just to listen to this recording, we're going to talk about CI/CD, infrastructure as code, today as the main theme. I'm sure there's a lot of things around there that we can talk about, but we'll stay close to the main theme there and see what we can share today.
Yeah, and if you don't already know, for example, if you haven't watched even one episode, they would probably explain this. I'll be coming with a bit more developer mindset, and Gyan will be bringing that DevOps mindset. That's right.
Yeah. So would you like to kick us off?
Sure. So CI/CD, it's continuous integration, continuous delivery. And what a lot of teams, companies, groups in general will try to do is set up some sort of automated pipeline that will manage a lot of their deployment process and making sure that the code they want to ship is easy to ship and that they can depend on that code. So they'll have a pipeline that'll do things like build their application, run tests against it. If those tests pass, make certain decisions. It might do then more tests that are perhaps slower, make more decisions, and eventually that image which is the version of their application, will be promoted somewhere. And if at that point there's a human stepping in, a human might step in and continue that process, or other companies will just have it fully automated where it'll say, as long as all of these different steps pass, the code will continue to be promoted up into some environment. And those environments could be a development environment where things are less stable, could be a staging environment, could be production. Really depends on the situation, depends on the code base, depends on the company. And we'll be talking about a lot of the tools that make that happen and how people can interact with these pipelines to make their lives easier without making it overly dangerous if something were to go wrong.
Yeah, couldn't have put it better myself. That was a really great introduction on CI/CD, even a little CT in there with the testing. I've seen a lot of articles do that where they're like CI/CD and CT because apparently testing is not part of deployment processes anymore.
This is the first time I've heard of CT, so
they do that.
You're breaking...
I've gone on many blog posts before where I was trying to search for better practices and such, and they're like, what about this new term, CT? And I was like, continuous testing? Or should you be just not testing anyways? So that's how the bad piece is.
Yeah, I was considering that to be part of integration.
Yeah, sometimes it's not.
Okay.
Because a very basic pipeline is just build and deploy. You, build some code and then you ship it onto a production server, which it could be as simple as you have a node image that builds out some static files and you copy it to a S3 bucket or something. Mm-hmm. There you go. Now you have continuous integration and deployment.
Yeah.
You are now DevOps certified and you can go apply for huge jobs.
I don't know. I've been doing that for a long time and I never felt too confident in my DevOps mindset.
That's your imposter syndrome and I can't help that.
Okay, fair enough. But with respect to those two things, you kind of there just combined the CI and the CD. So the way that I see, at least, or understand the CI is more like integrating new code into the code base. And then deployment is actually shipping that code to an environment where it runs. Is that how you see it?
Yes.
Okay.
Yeah. There's all these steps are supposed to have their individual responsibility defined. And that was just the most basic CI/CD pipeline example,
right,
where CD is the part where you're pushing to S3 where it's live, and CI part is where you build and get out the static assets.
Yes.
Then you start complexing it, right? But when you're starting building a pipeline, start with that, then add testing in there, then add more testing or environment production escalation, and there's a whole bunch of things there where you have to make sure the whatever binary packaging, container images, whatever you're building, they're mutable, immutable, depending on your environment. They change with environment variables. what commands they're going to run. All that is its own little beast. But yeah, all of those then go in the middle of that pipeline of, and that's the most basic pipeline, is because you need at least 2 flow points to go from A to B of build, deploy. And that's the most basic CI/CD pipeline that is actually used quite a bit in most SaaS products that they offer. I'm sure some people have already used those websites where it's like you link up your GitHub repo and it will give you a URL that's where it's deployed. And that's essentially all they're doing. They take your GitHub repo, build, copy assets. There's a web server serving things.
Mm-hmm. Yeah, so that all sounds great, but I'm just a little developer. Why do I need to care about how my system's deployed? Gyan.
It's a great question. In ye olden days, that was the thing. Their developer would develop their code. This works on my machine was the golden motto. And then it was just thrown over a wall. Just Kobe it
right
to the DevOps team. And they can take it. They can choose Windows, Linux servers. They can decide how it's deployed. They can scale it. It's their responsibility. I don't give a heck. And that's where I know. This is PG-13. I'm just feeling rebellious.
Wow.
But yeah, so that was the yield days. Unfortunately, it didn't work very well as the product matured and growed, because now you have developers building these things that goes to production, and then the production team says, this doesn't work on our production server, so then it gets thrown back to the developers, and the cycle continues, and it can take days, weeks, if not months, based on how bad or how big the product is and how competent your teams are.
Right.
Yeah, and that's where a lot of these frictions would happen, and to some extent that was justified because developers were super into code and they didn't need to know how these OSS were set up, how these Linux servers or Windows servers had to work, and that's where dev and ops were 2 different things, and now we've put them together in this beautiful DevOps worldview, and that's where CI/CD came to exist, where now that it's so easier to merge those 2 worlds, we needed some way of creating a flow between those 2 environments.
Right. So one of the things that I think is really valuable with the introduction of this approach is an iterative development process and the ability to develop in an environment that is very similar to what will be deployed. So what I mean by that is, for example, we use Docker a lot to build locally. And if you're building and running images that are going to be the same images that eventually get promoted into an environment, you can be much more confident that you won't run into the "it works on my machine" issue. And so at least if I step back and say, what's the big, most important part of this system of blending these 2 worlds together, it's that confidence that what I'm building is going to be the same as what they're trying to run. And so like I said, if I had to point to a piece, I think that's the critical piece. And then on either side of that slash between the CI and the CD, you've got a bit more developer heavy, and then you've got a bit more ops heavy. But as long as you're both working in that same simulated sort of environment, then it's that handoff is much less dangerous. You're no longer compiling something on one machine and hoping it works on another. You're saying, I have this image, I'm going to build this image, or use this image to build a bunch of containers. They should all look the same, and it should work the way it worked on my machine. Do you agree?
Yeah, and that's one of the benefits of DevOps, and primarily containerization, that has helped smooth that process out. But CI/CD existed a little before the whole container thing happened, and Docker became just my best friend.
Yes.
You were, before you came into my life, Docker was my best friend. Yeah, it just gave me joy, and I could run similar things everywhere. And even now, one of my my steps to debug anything is try to replicate production locally. That's the only way you can be sure. And Docker helps quite a bit with that. What CI/CD helped also to do is automate a lot of that process where, let's say, previously what developers were doing is they have this Java project and now they have to build out this binary. And what they were actually doing is they would build out these binaries on like whatever developer is senior developer or something. They have these. And then those get shipped off as like, I don't know, USBs, files, file share to people with instructions and steps of this is the environment you need, this is how you run this. And that's where CI/CD helped a lot, because now you have machines that can reliably build certain artifacts with a certain set of commands and deploy them.
Yes, because if there's one thing you've told me over the last few years, it's that people make mistakes, and you'd much rather just have a script do it instead of a human.
100%. Anything that's repeatable or boring or redundant should be done by machines. That's what machines were made for.
Mm-hmm.
Humans were made to create, because that's what humans do. They're good at creating, they're good at problem solving, they're good at somehow surviving, still not believing in vaccines. But they make those choices and they move forward with their life.
Mm-hmm.
And if a human has to run the same 6 commands every time they worked on a new feature, that's going to take away brain energy. And that's where CI/CD can come in, and machines can do all of these things for us, so we don't have to.
And one of those times, they might forget to run one of the 6 commands.
They might, and before you know it, your customers are getting a software where the payment system doesn't work because somebody forgot to compile that module.
Mm-hmm.
And but if it's a machine, it's reproducible every single time, so you know it works.
Yeah.
Or you know at least the given output is what it should be.
All right, so that's the benefit proposition, the problem it's trying to solve, blending these worlds of development and operations. Now I'd say we should probably start at one end, and I would propose the developer end, because I'm biased.
Okay.
And work our way through and say, like, what might a CI/CD pipeline look like when you're actually interacting with it? And then from there, we can say a little bit of specifics about tools if we want to. But I would say that since I'm already introducing this section, you don't seem to disagree, I'll just continue with, I consider the CI/CD pipeline starting with something as simple as linting and formatting. So oftentimes you can implement this with something like Git hooks to make it even closer to the developer. If you have a team that isn't a real pain about this sort of thing, you probably don't need those. But if they are going to be a pain and then try to force things through the pipeline as soon as their linting errors show up, it can be nice to just bring those things closer to the developer. So one of the things that, for those who might not be familiar, linting and formatting will do is you can run it against your code and it'll tell you if you have stylistic errors that can be caught statically, or if you have a formatter, it just makes sure all your code looks the same, with the goals of both of those being avoiding common errors and making it look like the code was all written by the same person as much as possible, so that you're not worried about stylistic differences switching between parts of the code. And that's very much a code level issue. It's not an application level issue. So it's very, very local, but that can get addressed at like step 1 in the pipeline. It's super fast. You want a fast turnaround time for that. You don't want to wait for 30 minutes for a bunch of tests to run, and then you find out you had missed a semicolon and you're using a language that has optional semicolons, but you're supposed to have them, so then you get an error and you have to rebuild that all over again. That's really slow. So something like this goes really early in the pipeline, standardize a bunch of things, but you get quick feedback. After that, you might go to something like unit tests. And that would be, again, hopefully, tests that run quickly. And if you have a lot of unit tests, you might even choose to do something like a subset for critical features, something like that. You want something that runs as quickly as possible, that you really care if it fails. Again, to limit that time of the feedback so that you don't have a developer thinking something's done, waiting 45 minutes, finding out something seemingly trivial is broken, or something that they could have fixed right then and there with a couple minutes of work is broken, and then having to wait another 45 minutes. especially if you're trying to escalate something quickly because it's broken. You want these things to be in a logical order. Where would you go after that, Gyan?
Yeah. So at least from the developer's point of view, that makes sense. As a developer myself, that was something I always looked for while designing these pipelines, or at least when I'm using one, is developers only care about, did my code do good? They don't care about how the pipeline is scaling, if things are working fast or not. They just want to know if they messed up, they learn it the quickest way. And that's where that communication is really important between dev and ops, because they might give you a checklist and say, I want you to run this UI test, these linting, these formatting, and the ops person might not know what's important or what should go first, so they just make sure they're all either parallel or in a sequence, depending on what they think is the best resource usage.
Right.
And then it turns out, like you said, you wait for 40 minutes after all your UI tests and everything has worked, and then linter comes and is like, I'm sorry, there was a weird space at the end of one of your lines, and now this pull request is rejected. Please run through 45 minutes of turmoil again. And yeah, so that's where, at least from a developer's perspective, did it run? Is it good? And if I can check the logs, that's the most important, like some sort of notification. Most of those are generally hooked up by GitHub hooks, wherever your repository is when it reports back saying if things fail, it gives you a little link or a URL so you can go look at the logs and figure out what went wrong so you can fix it, and you don't have to wait for the ops person to tell you what went wrong, because they're the only ones with access to logs.
Mm-hmm. And if you're using something like Jenkins, you'll see that in the pipeline itself. It'll usually show you the standard out that's coming from your tests or whatever stage is running. And the nice part about, again, the tools that we tend to use is the logs that you'll see there, or the error messages, will typically look the same as if you were to build and run those same things locally. So one of the steps the first step that I'll usually take if I see something blew up in the pipeline that I wasn't expecting is see if I can recreate that locally. And the nice thing about, again, being based off of images is if I can't, it's probably something to do with the differencing environment and not something to do with the code level itself. Because if it works in one place based on that code and not in another place, it's likely a configuration error. And you can start looking at your environment level config files. So yes, access to logs are important, and it helps you with narrowing down the potential areas of where the reason why something might have gone wrong is what I'm trying to say. But what I was getting at is you've got unit tests or a subset of tests that they fail quickly. After that, you might do something like your integration tests, which typically will take longer than unit tests. That might not be the case depending on how many you have. But for example, if we're building and running and testing a front-end application, we want to run absolutely everything in the pipeline that we possibly can before we get to something like browser-based Cypress testing, because those are crazy slow. And every time somebody complains about how long a front-end pipeline takes, it's pretty much always, sorry, 88% of it is spent running browser-based automation testing. And unless you can speed those up, there's not a whole lot we can do. And unfortunately, they just take a long time. And so you don't, again, want to find out after those are done that something unrelated has failed. So those will tend to go last. And at that point, if you've run all of your tests, you've run your slowest tests at the end, you're probably ready to start doing something like signing off in an automated way on that build.
Yeah. And then you tag them whatever way is needed, escalate them if needed, and yeah.
Right.
And then there's some human intervention there.
Right. So again, what do we do with the images after they've been spat out of the pipeline?
Oh, we put them in a central repository. We put them somewhere you can access them so that depending on the processes you have set up, if you have automated versus even just, I don't know, let's say you have a QA department because you don't trust the machines to do your testing. So you have all these images. Now you can push them up with the PR number or anything with tags. and then your QA team can run them on their own computers and do all their testing and figure out what they want to, how they feel about it.
Right. Yeah. So QA could pull it down, build it on their machine. You could get, if you're doing QA before it gets merged into the base branch, you can do something like a ticket-based or PR-based environment where QA can log into that environment and do testing on there, so it's specific to the code changes made in that PR. Or a way that it's currently done where I work is once those are merged into the development branch, they're automatically deployed to an development environment because we don't care if that environment gets broken. And so at that point, we're like, yeah, the code looked good. Developer said it wasn't breaking anything. Push it to development. There's nobody using it other than developers and QA. So at that point, QA can log in, see what's going on with the feature, make sure it doesn't seem to have broken anything else. And those images will live in different environments. So we'll have a image repository for development builds, and only once QA has signed off on those builds and we're ready to actually put them into production, do those images go through their own image promotion pipeline and get promoted into a new repository that's just for production images. And that way, anytime you want to roll back, you can, if you were to roll back, you just have a collection of valid production ready images. And for any reason you might want that collection, it might not just be for rollbacks, but you know you've got this signed off on polished set of images, and yeah, it's not all mixed up with development builds that could be broken in all kinds of ways.
Yeah, and you know, they don't have to be, one of the things while we were talking about that reminded me of how some people feel the need that they all have to be sequential. For example, now that this has been escalated to production and is in the production image or production place, you immediately now have to turn the production environment with this latest image. Even though you could do that, and there is lots of ways you can do it with like blue-green deployments or whatever to make sure it's the least amount of downtime. One of the practices that I was reading about that I actually liked quite well is figure out what time your customers aren't using the product very much, where your traffic is extremely low or maybe non-existent, and you have a job that goes in, pulls out the latest image, deploys it, and just checks to make sure that page loads or things are working. In that kind of scenario, you have to really, really trust your escalation process that whatever's in the production repo is now pristine. And worst case scenario, again, you have your own rollback images where you come back, you say, oh, this isn't right, you press a Jenkins job or a button, and then it just rolls back to the last successful environment. Mm-hmm. That's the one I've seen to like avoid most problems of hot deployment, where you don't want to give any downtime, you want to make sure things are getting pushed. And that's where they add a little packaging environment in between, where even your QA can pull down the latest production image that looks good, and just make sure it's working because it has all the environment variables and everything it needs. And if it doesn't, they can just send a bug request, and before it gets actually sent to production, somebody can fix it and redeploy. It's like sort of a pseudo production that exists until you push it out to real customers.
Mm-hmm. Yeah, ours, because it's just in a repository, it can be very asynchronous. So you might promote that image because we have a number of different services. And so if we decide we're going to do a release and it's going to include 4 or 5 services, we might promote a few of those services, then find out that there's some sort of regression in one of the services, or that something's being escalated and needs to go out in this release now. Well, it doesn't matter that we already promoted the unrelated services. Those images can sit there. And unless we have to make any changes to those repositories, they don't need to be rebuilt. And then we can just rebuild that service that has an issue or needs to be upgraded, update it. It gets to its own promotion pipeline. It might be days later that it gets promoted. Now everything's in place and we can start doing the rollout. And then with the rollout, again, as you mentioned, because everything is, or there's different strategies for rolling these things out. You can do something like a canary deployment, deploy to a small section, make sure that that traffic is being handled properly, particularly if you have something that needs to be backwards compatible. That can be a really good way of doing it because you're rolling out a subset of the system. You're like, if this explodes, we really don't want to roll this out. You roll that out to a small section, make sure everything seems okay, and then flip all your traffic over to use that image. You could do something like the blue-green, or whatever the colors are. You roll it out, and then you end up just pointing all of your systems over to that new section once you've signed off on it. So essentially you have like 2 versions running. You say, this is the live version. All right, but this is the new live version, and we're going to point everything at that. And then you can take down the old version. Ours is kind of more like that, except that it's just strictly rolling. So it'll do like a service at a time. We're like, is it good? Yep, flip it over. Is it good? Yep, flip it over. And if something blows up, then both services are left running, but no traffic is running over to that one yet, because we've realized something went horribly wrong. We need to deal with it. And having all of these orchestration tools in place makes it much more accessible to the development team to be able to handle things like that. It's pretty infrequent that we have an actual ops person from the ops team as part of our standard deployments, because we have all these tools in place that are making sure that our images are built the way that we expect them to be, and all the systems monitoring our processes. So like if the metrics start going crazy on something, an ops person is going to show up. But if the metrics look normal and we're just doing a deployment, all the systems seem happy, they don't need to be there because they built these systems so that they don't have to be there. And to go back to, again, the DevOps mindset, so to speak, it's, I think, a benefit to be able to have the DevOps influence without having an actual DevOps person there, ops person there.
Yeah, I think at most when like having a ops person is one of their biggest, I guess we're sort of quasi transitioning to the ops person's perspective on this, is their whole responsibility is to make sure the developer has all the tools they need to know that they did good.
Mm-hmm.
That's like one of the major parts, and then the rest of the responsibilities is that, hey, now that it's actually deployed, we need to make sure things don't go down, monitor systems are working, and they have to implement a lot of things like self-healing deployments. If something does break, it automatically goes back to the last working thing.
Yeah.
And there's a whole 12 principle methodology thing that I used to have pasted on my desk to know what I know and what I can fix if something goes wrong. It was sort of this deployment Bible for CI/CD people. It was pretty great. Single page Bible, if that's a thing.
Nice.
And yeah,
I think that's more of a tablet
easy.
or a manuscript.
It was the 12 commandments.
There you go. Perfect.
That we used.
Yeah.
And it was that those were the 2 responsibilities. One, to make sure developers have everything they need to make sure deployments are successful. And if they go wrong, they can figure out why without pinging you. And then on the other aspect is, once these are successful, everything's working great, hallelujah, let's figure out things don't break or things don't die at the middle of nights. And that's where they can also look at and say, hey, with this recent deployment, the CPU usage has increased 40%. Did you guys actually intend this? And that's where a lot of those ops people have to now figure out and make sure they have all these things in place.
Mm-hmm. Yeah, so I think part of the last few months of chatting with you even has showed me a lot more of how the line between ops and developers is so blurry compared to what it has been on the teams I've worked on. So like outside of this imaginary world of startups in Victoria, BC, like the real world has a big blend here between these 2 skill sets. And this is part of why I have these certifications that I'm trying to do to get better at the part that I don't have as much familiarity with. And a lot of these practices inform why those skills are important. So there's always that question of how much outside of your immediate skill set should you be trying to learn. And I think if you have no idea how any of these tools are working and you're beyond an entry-level junior developer, it's probably worth a bit of your time to get familiar with what the pipeline's actually doing, even if you couldn't explain the purpose of Jenkins very clearly, if you understand we're using this tool that runs our tests and builds sort of like it does on my machine and then ships it somewhere. And that gets tested by somebody else. And then that does a thing, that eventually reaches production. Like if you have a general idea of, at least on your team, what's happening with your code, that I think should at least pique your curiosity enough that if you are interested in those things, you can dive more deeply. But if you have no idea, it's tough to even have any sense of what you don't know that you don't know. And it's a big wide world out there. People get paid full time to maintain these sorts of systems. So if you have no idea how it's going or how it's working, you are missing out on a lot.
Yeah, and then the curiosity part is very important because you have to, at some point, at least if you're a strong intermediate to senior, and you're a developer, you should be talking to the ops team quite a bit, especially when you're doing deployments and figuring out how these things run away from your system. If you give them a set of commands, or you're setting scripts up, or they're setting things up, you should be able to recreate and run those things locally on your computer. And more importantly, you should talk to them on what are the limitations they might be facing. I remember we were running these certain set of tests, and a lot of them were failing because the runner machines we had only 64 gigs of RAM. And these things were beasts. They were just going more and more, and then the out of memory error would kill them. And we talked to the developers and we said, this is happening. We have to now create bigger machines for you guys, so it's going to take a couple of times. And they said, oh, we can just set a flag which restricts it to that, and it'll still do the job. And we were just there, sad, sitting, because we have no clue about that code base. We don't develop these things. And as your product grows and matures and you have different teams, like let's say a gaming company, you don't know how to make these games. You don't know what's going in the engine.
Mm-hmm.
You're just there because you were given a certain set of commands and be told to run these on a basis of commits and such. And then, so as a developer, it is sort of your responsibility, at least morally, if not on paper, to go figure out where your code is running on these different environments, that it's actually running under the circumstances you would expect it to, or if you can optimize it to be better.
Mm-hmm.
That's like sort of a hidden rant from a DevOps person, from the ops perspective, of just don't push any code, okay? If you can make sure it works in smaller requirements or figure out where it's running, do that, because your own machine is running 120 gigs of RAM, and that's great, but I can't replicate that easily. Yeah.
Yes, the operating costs will
exactly, and that's one of the huge overhead ops people have to like think about and be under all the time, because there's no such thing as unlimited servers. As much as Amazon pushes that, they charge you money for it.
Yes.
Yeah, you're like virtually scalability infinite, and you're like, oh, that's great. So if I spend 10 more EC2 instances, it should be fine. And then you turn out you're paying $5,000 more a month because you didn't contain the limits and resources you were supposed to be in.
Mm-hmm.
And that's where that communication is really necessary, because they could come to the developer and say, oh, you don't have to run these in parallel. You can run them sequentially. This part of the branch, we don't need to know things immediately. And then you're like, I just saved like $100 a day or something just by reducing this. And
yeah. I haven't talked to a single ops team or person that's in charge of setting up Amazon stuff that isn't wishing they spent a lot less on Amazon. These things are a huge point of spending and a lot of overhead for a company. So being haphazard about the resources that you require in your code is definitely a problem, especially if you're working with a small company. And if you can directly influence the cost basically of running your software in a positive direction, that's not only good for you, it's good for the company, which is indirectly good for you. Because if you're working with a small company, there's always that question of if they'll stay in business. And if you're doubling their operating expenses, just because you're demanding more resources every time you deploy, it's not ideal.
That's true. Another pro tip, though, put time.sleep in all your code and then remove it as customers complain about slow times. And then you're going to be like, I improved efficiency by 110-fold.
This is the classic Gyan, break something and then fix it, but only tell people when you fixed it.
Yes. That's how you make sure you have a job.
Right.
That's the DevOps mindset. You break things in a way that nobody else can understand how you broke them. So you're the only one who can fix them.
Yeah.
And 100%. 10 out of 10 would recommend. If any of my previous employers are listening to this is a joke. Please don't sue me. I did all the best I could.
I've worked with a few people that seem to have that mindset though of I broke it, but I won't mention it until I fix it, and then just say it was broken. I don't know why, but I fixed it, so it's fine now. And everybody gives you the claps and the 100% and the ta-das, the party parrots. Everybody's excited that it's fixed. No questions about why it broke.
Until you go in the Git history, and you're like, hey,
hey, I see that name.
Yeah, and I guess that's where a great segue into our other topic, infrastructure as code.
Oh yeah, I almost forgot all about it. So I first heard about infrastructure, or I shouldn't say heard about, I first got into the tooling around infrastructure as code like 2 years ago. I took a course about Chef and Puppet and then decided that I wasn't interested and sort of just ignored it for a couple of years and just tried to be a really good developer. And, eventually I realized that this is a big hole in my knowledge and I need to learn more about it. So I mentioned this a few weeks ago on the podcast, but I was working with CloudFormation on AWS to spin up a Minecraft server, and it just reminded me of how interesting I thought all this was before I decided that I just wanted to focus on the development side, because it is really nice having code, because I didn't explain this ahead of time, code that represents the infrastructure that you want to spin up. So in the case of that sort of server on AWS or environment on AWS, describing all of these instances, security groups, everything that's baked around this entire environment that you want to build in it's probably a YAML file, I don't even remember at this point, usually YAML, and then just shipping that off and having a system that takes care of managing all those different resources. It's so consistent and dependable and declarative and cool. And it's weird that I don't like it more than I do, but I'm sure once I get into it, I'll really like it because it has all of the things that I like. Being consistent, declarative, and cool.
I agree. I often joke around the fact that ever since I got really into DevOps, that I'm not a C++ or Java or, Python developer. I'm a YAML developer because all I do is write config files and syntaxes and make sure infrastructure is represented in a certain manner. And that's because we have all these helpful tools. I no longer have to create these huge libraries and scripts that goes in and pings servers or installs the software, checks for it, looks back at the echo in Bash or whatever. I can go write a little Ansible book, a role book, and it goes and executes it. I can go write a little chef recipe, and it ensures everything works. And I'm sure we can do a whole episode on all these different tools and how they're great. But at least from a very, very overview level, Eagle View Vision, that's what they all do. You tell them, I want 5 servers on this area, and all of them needs to have these 10 software installed, and you write this in little syntax files, and they just go and do it, and it's beautiful, and it's one of those great things of I am happy to be alive moments, as I feel very strongly as an ops person.
Combine that with orchestration tools, and you just watch everything roll out as your big fleet. It's very satisfying.
Having an end-to-end pipeline is like once you build it, it's one of those like I did something good with my life moments. Even though like at the last job the infrastructure I built it on was very unstable, I was immensely proud of the fact that it was running 10 different command lines and tooling all written manually, just getting your code from GitHub all the way to production. And I was very happy and proud of that, because it's just very nice to look at that and look at your little JSON files for Kubernetes, having resources and everything defined, not worrying about going into each system, yum install this, yum update that.
Right. This is something that we glossed over, but I would like you to just very briefly describe what things were like without infrastructure as code. What does setting this stuff up look like without that? And then in contrast, infrastructure as code.
Yes. So one of the great examples that I recently went through is I set up this EKS cluster, which is the Elastic Kubernetes service on Amazon. And essentially, there's 3 ways you can set it up. 1, you manually go through the UI. You set up a EC2 instance or multiple of them based on their size. You run a little Kubernetes server, and then you connect all the other instances with it so that it runs in parallel. Average time, if you're already familiar with this, might take you 2 to 3 days to finish all of it. The second easier way is using EKS. You go through their GUI, you put out all the things that you need in your format, and you define all the instances you need, you define the security groups. If you're familiar, about time that'll take you to fill out these things and create something, I don't know, like 2 hours, 3 hours. And then finally, the tool I learned, CloudFormation, and I have these YAML files that are, which is even better. Amazon now has this command line tool for EKS where it uses CloudFormation to create those. So you define YAML for EKS, it translates that into CloudFormation, and then it deploys. It's just beautiful to watch. But the YAML file setting up, if we discount the time of me reading the documentation and understanding the tool, took me less than 10 minutes of figuring out what are the things I need. These are the security groups, these are the VPC subnets. I just fill out all this in one single line, and I have a Elastic Kubernetes fleet on my hand. And the great thing about it, as opposed to go through the GUI, is if something goes wrong, I have to go through the GUI, I edit it again, delete things. I run a single command. That's what my README is. To recreate this, run this command, and you're done. And you're just happy. You want to go out and smell the roses because you have time, because it only took you 10 minutes to run these commands. And while Amazon executes it, you're happy. Mm-hmm. It's just, life has meaning again.
Yeah, even just the simple things that I'm more familiar with, like saying how many instances you want of something, and then just being able to, for example, if we had a issue a few weeks ago where one of our pipelines was backing up, and we're like, oh, let's just add some more workers to that pipeline. You just increase the number, and they just spin up because the system's taking care of that for you. And then when the extra spike in traffic was over, we're like, all right, just roll it back down. And when you've got something like a automatic or auto scaling group, then that's already taken care of for you. So you're just handle the load. This is the max number. This is the min number I want. These things are so, I don't want to say simplified, but that's kind of what they are in a way. The underlying complexity is there in the same amount, but you don't have to spend the time, as you said, clicking through UIs. If things change, you don't have to try to remember what you did in the UI before. If somebody goes in, this is another thing about having code as part of it, is you get version control, and you can see the history. Oh, it was working on the 8th, it's now the 10th, but it broke on the 9th. What happened on the 9th? Oh, Timmy went in there and decided to change this URL endpoint to this URL endpoint in this config file. We can now see that. Timmy decided to take the size of our instances and cut them in half. And it's well, why did you do that? You thought you could save some money. Well, clearly it's not working because the system tipped over. These sorts of things are trackable if you have them in code. They're not necessarily trackable unless you have some sort of audit log on your system if you're all doing it through the UI.
Yeah, and then you find out a concerning part of that is you have an adult named Timmy in your office. And you just need to make some...
It was a poor hiring decision. It was one of those sympathy hires.
Okay. He was just in grade 6. He had just built his first Hello World in HTML, and they're like, hey, go ahead.
He had that go-getter mindset. He just had none of the
Okay.
skills.
Okay.
So
Well,
if you're
at least
familiar
she's got
with
one of them.
the Dunning-Kruger effect, he was like right in there at peak. I know everything. Before the
I'm sure
trough.
Kimmy learned a huge lesson there.
Yeah. He's now in the imposter syndrome trough where I live.
Well, poor Timmy, but I'm happy he was a go-getter mindset.
Mm-hmm.
And yeah, that's exactly it. The ease of having everything as code is you can go in, alter certain things, see how they're behaving over a couple of days, and you're done. And yeah, let's say some of your builds are starting to fail because you're missing Vim on the machine because your developers thought it would be cool to use that. And now you can have that in the code. Just top-notch quality.
Yeah.
And yeah, and then you're at least next day somebody looks at it and figures out what went wrong. They could all look at it and say, oh, okay, the changes I made required this new software to be installed at the OS level. And let's say you have a fleet of 20 servers. If they were manually created, now you have to SSH into one of those, yum install the same command over and over. And at that point, life is just not good. That's when you start questioning everything.
Yeah, some would say this is not 2021 level quality.
It is really not. And that's when these tools with the infrastructure as code and handy help you out quite a bit, immensely.
So you hear that, listener? It's 2021. It's time to enjoy your life. It's time to use infrastructure as code.
Greatest year so far.
Best year of my life so far. One day in, and it's been excellent.
Would recommend.
10 out of 10.
21 out of 20.
Yeah, I guess 1 out of 1 because we're one day. But either way, 100% is the point.
100% success so far.
Yeah, big fan. Do you have anything else to add? That's pretty much all I have for at least this level of discussion with infrastructure as code and CI/CD.
That's where I had as well most of it. And then depending if there's any follow-ups and everything, we can touch on more of these in depth. One of the things I did wanted to mention is, as much as I love infrastructure as code, there are over engineers and certain things get sad. So when you're creating these things, maybe keep in mind, like if you're creating a little proof of concept, maybe don't worry about investing time in creating these YAML files or learning the syntax if you don't already know, because CloudFormation, if it fails, it straight up fails, rolls back everything, and then you have to start from scratch. So it requires a lot of patience if you don't know what you're doing. And like let's say you're just going in to set up a little Postgres server on an EC2 instance or a little Nginx server, and you just want to learn how these things work. You could burden yourself quite a bit by trying to create a CloudFormation template, learning how that works, learning how that integrates with EC2 and everything. So don't do that. And Nathan has his hand raised up.
Yes, correct me if I'm wrong. A lot of the services and tools that you'll use also often provide like a download JSON to see the current configuration, right? So if you were to do something like a proof of concept and you were doing a lot of fiddling early on and then you got it working, presumably at that point you could at least download the current configuration and say like this was what it looked like when it was working.
Yes, yeah. And where I don't recommend is like the infrastructure, because anytime there's a new hot practice, sometimes beginners get thrown into those articles.
Yes.
And if you don't know anything about these things, when you look at a CloudFormation template and it says enter a value for AZ subnet, you don't know what that means. You don't know what is CIDR, what are these IP ranges, why do I care about any of this, what is VPC? And that's when it's better to go through the UI, because you can click on a billion little question mark symbols and learn about all of these and go through the slow little process.
As someone who has needed those question marks, they aren't always as helpful as you wish they were because they still use the terminology that you don't understand.
Yes, but sometimes they have this little learn more, and then it takes you another page where you get confused even more.
Correct.
But now you're confused with more data, so you feel a little better.
Oh, okay. Well, I feel much worse at that point, but I guess different effects on different people.
Yes. Yeah. I just look at everything in the positive light. So if I'm confused with more data, I'm like, wow, now I'm in bigger confusion. At least now I'm confused for a different thing than I was before. So life is good.
Okay. All right.
Change is great.
Okay. All right. I like that influence that it may have on me and my mindset in 2021.
2021. Yeah. But yeah, that was on my list. And yeah, we touched on CloudFormation, Chef, Ansible very briefly. Another name I'll just drop in, Terraform. Look at it if you're proficient enough to go multiple cloud providers and everything. But yeah, and we can definitely do follow-up episodes on more in depth of these tools and how they run and what are the infrastructure and architecture behind them.
Yeah.
But for now, this is a good overview.
Yeah, and hopefully by that point, I'll have a bit more knowledge and I can have some opinions so I can actually argue with Gyan. Because right now, I'm just a noob and he's the expert. So if he says something, I'm like, oh, okay.
You want to make sure you have the gobblegoop in all the load balancers.
The gobbledygook, yes.
Yeah.
Right, I forgot that. I put in the VPC subnet and then I don't know.
You forgot the gobbledygook.
The gobbledygook.
That's how you get hacked.
Oh man. All right. Well, I'll write that down. Make sure that I have the gobbledygook on my certification exam.
And if it's not there, then it's the wrong exam. Don't
oh no.
Lose whatever hundreds of dollars you're investing into this.
Sweet.
Yeah.
All right. Well, I'm glad that I have something to take away from this conversation. But next week, what are you doing to do better?
Well, it's the first week of 2021.
It is.
And
as we've mentioned.
Going to be, as we've mentioned plenty of times, I don't know why. What I'm going to do is, this is the week I'm going to take to do a reflection plus resolution. So, as with every normal person on the first week of January, for whatever reason, I'm going to make new resolutions. Which, I mean, is really just a continuation of resolutions I'm already making, but it's with a new attitude. Great attitude. Same old me, great new attitude. And so what I'm going to do is I'm going to sit back, think about the previous year, and then think about what resolutions I make. And by the end of the week, I will have a list. And the next thing is I'm pushing my bedtime from 6 to 5:30 a.m. I don't have any plans of going any further than that. But I'm just doing it because my gym opens at 6 and I would like to be there at 6 if I start waking up at 5:30.
Yeah, there is a point of diminishing returns with early bedtimes or early morning wake-ups.
Don't you wake up at like 4?
Yeah, during the winter I intentionally push my bedtime ahead because it's dark for so long. There's something about being awake for 4.5 hours before the sun comes up that's just not quite so fun. Although it started happening again accidentally, just because it's dark for so long, that 7:30 rolls around, and I'm like, oh, it's time for bed. It's been dark for a while. So at that point, you just end up waking up early again, if you're me. So, but my point...
But I heard you were one of those people who only works when it's light outside because that attracts bugs.
That's right. Yes, light attracts bugs. So that's why I work in the dark. And somebody made me turn on the lights in my room for this call. I was trying to keep the lights off, and he's like, ugh, it's too dark for your recording. It looks bad.
I stand by it.
Okay, well, for all the complaints I know I'm going to get about it being too bright in my room, because everybody else is going to agree with me, I'm sorry. You can blame Gyan.
Yeah, look out for that Twitter poll. As soon as this episode gets dropped, we're asking for that.
Yeah, that'll be top of mind for me, like late February, early March, this Twitter poll. But I guess for me, in the next week, I'm just going to be continuing with this AWS Solutions Architect course. I've decided, because I did my 2021 goals last week, one of them is to try to get all 3 associate level certifications this year. And realistically, the hardest one will probably be the SysOps admin one, because everything online says it's the hardest, and because it's the one I'm probably least familiar with. So going through Solutions Architect, apparently there's a lot of overlap with developer, so I'll do that next. And then hopefully giving myself the second half of the year, if I need it, to get through the SysOps admin. And if they come out with a 4th, because I saw that they have a 4th one in beta, I'm not adding it. I'm not saying I'm doing all the associates. At this moment in time, there are 3 associates. That's my current goal. If I finish early, maybe I'll try to get that other one. But in the meantime, those are the three. So with the book behind me, because I don't need to read that anymore, I'll be focusing fully on AWS Solutions Architect and system design
like a
in
hot
general.
plan.
Yeah.
I'm looking forward to it.
Oh, good.
Because then I can copy off your exam.
Yes. Yeah, that's how these things work.
Yeah. I actually have been wanting to do that for the longest time, so I'm just going to piggyback off of you.
Okay.
Once you do one, then I'll be like, okay, how was that experience? And then I'll like steal all your notes,
Mm-hmm.
and then I'm gonna go take it myself.
Yeah.
And then
my notes are all written in Vim, so I'll just send you the swap
it's better.
files.
I don't know how to quit Vim, so I'll never escape the notes.
Yeah, obviously it has no effect on the file. It's just a markdown file, but
I can only open them in Vim.
Yeah. Cool.
Okay, whatever my master says, I have to. The teacher is always right, so you just do that.
Yeah. Facts. So that's my plan for the week. Sounds like you got yours. Anything else before we say goodbye?
No. Just looking forward to this awesome year, which people will hear 3 months later.
Heck yes. I hope it's been going great for everybody. We just got here and we're happy to be here. Thanks for listening.
Bye.
Bye.